So, hello friends. In this lecture, I am going to discuss about the Maxwell equation. So, before study of the Maxwell equation, all the students must have the basic knowledge of the vectors. Then you have must know about the vector calculus, such as the dot product, cross product, and curl of the vector, divergence of the vector. Then you must also know about the surface integral, line integral, volume integral, and then at last you have also the knowledge of the coordinate system, especially the 3D coordinate system, such as the rectangular, spherical, and cylindrical coordinate system. You have also understanding of the conversion from the one coordinate system to another coordinate system, how we represent the line integral, surface integral, and volume integral in different coordinate systems such as rectangular, spherical, and cylindrical. So any students have the basic understanding of all these topics are able to understand what is the Maxwell equation and its derivation. So in this lecture, I am just cover a Maxwell equation, and then in continuation in the next lecture, I am cover each and every the Maxwell equation and its derivation. So the basically the outline of this particular lecture is what are the historical perspectives of the Maxwell equation, what is the Maxwell equation in static form, then Maxwell equation in time varying cases. So first, basically, James Clerk Maxwell is the founder of the electromagnetic field theory. He first published the theory of electricity and magnetism through series of the paper published between the 1950 to 1915 to 1970. So basically, it consists of all previous experimental and theoretical results. So basically, the Maxwell summarized all the previous experimental and theoretical result that are published by the many people, or which is basically the contributed by the many people. And Maxwell is introducing the displacement current. He also predict the existence of electromagnetic field by unified electricity and magnetism. Basically, he is the first person who predicted the existence of electromagnetic field. But Hertz is a scientist who successfully demonstrated the radio waves. He is able to generate and detect radio waves. Then what's about the Maxwell equation? So it is basically the fundamental equation of electromagnetics. It's basically to describe electric and magnetic field in dynamic on or time varying scenario where electric and magnetic field are interdependent. See this particular diagram where we see that a moving electric and magnetic field. Here the electric field is represented in X, then it's moved to the Y. But electric field and magnetic field always perpendicular to each other. Similarly, this electric field and magnetic field is propagated along the Z direction. So the electric field, magnetic field, and the direction of the propagation all are perpendicular to the each other. So this is the basically the behavior of the electromagnetic field in a particular medium. So basically, a time varying field are due to the oscillated charges, are time varying charges. Example of the time varying field are oscillated charges is the pulsating current flowing in the circuit. Similarly, in a time varying electric and magnetic field is represented by EXYZT and XHYXYZT, where EXYZ is basically the electric field in a rectangular coordinate system. If it is in a cylindrical coordinate system, then it is r phi z, and if it is a spherical coordinate system, then it is r theta phi, and t is basically the time. So any electric field is represented by any equation with E, where in the form of the independent variable x, y, z, t, or if it is in rectangular coordinate system. Then, if you summarize, basically the electric charges is responsible for electrostatic field. Stationary charges is responsible for electrostatic field. Steady current is responsible for the magnetic field, and time varying current is responsible for the electromagnetic field. And basically the Maxwell equations represent time varying fields. Then we summarize Maxwell equation for the static form. The Maxwell first equation is derived from the Gauss law. Detail will cover in the later lectures. Similarly, Maxwell's second equation is the basically due to the non-existence of isolated magnetic field. We all are familiar with this particular concept. It is generally basically we are not able to separate the north and south pole in a particular the magnet. That is also the non that is basically responsible for the non-existence of isolated magnetic field. Similarly, the electrostatic field in any medium is basically conservative nature, so del cross E is equal to the 0. And last Maxwell equation is derived from the Ampere's law. It is represented as del cross H is equal to J. Similarly, this Maxwell equation is also represented in an integral form also. And basically this particular del dot D is nothing but the divergence, and del cross is nothing but the curl of the electric field. Similarly, for the time varying cases, the two Maxwell equation is modified when one is the third Maxwell equation that is derived from the Faraday law, and it is represented by del cross E is equal to minus del V upon del T. In the static case, the del cross E is equal to the 0 because of the conservative nature of the electrostatic. But in the case of the time varying cases, the del cross E is equal to minus del V upon del T, that is nothing but the Faraday law. Similarly, the Ampere circuital law is also modified for the time varying cases, because in the time varying cases, we introduce the concept of the displacement current, where the del cross H is equal to J. It represents actually the conduction current. J is actually a conduction current, and del D upon del T is the displacement current. So the Maxwell is the responsible for introducing the displacement current in the displacement current, and he modified this Ampere circuital law equation. So that is all about the Maxwell equation. In the later lectures, I am going to discuss about each of the Maxwell equation in detail along with the derivations. So thank you for your attention.